Hello everyone. Today I'm going to do a video on enabling the new feature that IBM has introduced on their new SVC code 7.7, the endport ID virtualization. There's a great write-up on this on Barry White's blog that goes into detail what exactly they're trying to accomplish with endport ID. Basically, in a summary, high-level summary, what they're doing is they are presenting a virtual worldwide port name at the port layer, so that if a failed node were to occur, that virtual worldwide port name would be passed over to the surviving node and be presented. This eliminates any multipath issues at the host layer, MPIO drivers and whatnot. Sometimes you can have some issues there where the path won't come back online. The host won't scan for new paths, or there's a number of things that could go wrong. So the SVC team has decided that to eliminate any of those issues, we're just going to move the worldwide port name over to the surviving node, and the host will be unaware of the failure. So I'm going to go into how you set that up on an existing system. You can also use this for a new system, but I'm going to do it on an existing system and show that process. Right now I've got Barry White's blog post up about it. I'll attach the URL later in the video, but it goes into detail how it works, and if a failure to occur, how each port would take over, and it's a really good write-up. So anyway, I will let's move on to actually setting it up. Okay, so I'm logged into our V7000 here at our office, our lab environment. What I'm showing you here is the IO group, which we only have one IO group 0. And the setting that we're going to be adjusting is FC target port mode, which is currently disabled, but we will be changing that, and that's the parameter you change to enable this new feature. So I'm going to show you how to do that, but first I want to show you the actual ports on this V7000. You can see it has worldwide port names that end in Echo Charlie and Echo Delta. And if we go over and look at our fabric, which in our case we only have a single fabric, so it makes it a little easier to demonstrate this, but in most environments you're going to have dual fabrics. So I'm going to search for those two endings in worldwide port names. So we have a single port on Echo Charlie, and excuse me, Echo Delta, and we have a single port. So we have a single port from each canister. We don't have a lot of traffic going on in this environment, so that's enough for us. But it'll be easy to demonstrate this with the two single ports. So let's. What we're going to do is we're going to change this parameter right here to transitional. So there's two stages. There's transitional and there's enabled. When you do transitional, it allows the host to still access the physical worldwide port names and do I/O to the physical ports, as well as the new virtual worldwide port names. So for existing environments, this is the perfect sweet spot. You set it's transitional. Your new hosts that go in, they'll go to the new virtual worldwide port names. Your existing hosts that are running can still access the physical ports, and the idea is you slowly change zoning on those existing hosts and IPL them, or you add paths and slowly migrate off of those physical worldwide port names before you enable it. Once you enable it, you no longer can use those physical worldwide port names at a host layer. If you do accidentally, and if you enable it and your zoning is not correct, I/O will cease. You won't be able to access your LUNs. So you really need to make sure that you've got your zoning correct before you change it to enabled. Couple notes as well. This is for hosts only. If you're managing external storage or the intercluster links on a traditional SVC setup, those will still use the physical worldwide port names. This is only for host activity. It's, like I said, it's to address MPIO driver issues. So your physical layers, they don't need to use these. It's just for hosts. All right. So let's actually change it to transitional and see what happens. So we're going to do a change IO group, FC target port mode transitional 0 for IO group 0. Now we go LS IO group 0. You can see it's set to transitional. So let's go look at our fabric now. We'll do the same search. So now we have two worldwide port names checking in. They're coming in over the same cable, obviously, because it's a virtual worldwide port name. You can see here, this was the physical right here, the 215 Charlie Echo Charlie. Now we have this other one that's 255 Charlie Echo Charlie. So you'll see a pattern when you do this. It's usually 4 digits above the physical worldwide port name. So 255 Charlie Echo Charlie is our virtual, and the same thing applies here, 255 Charlie Echo Delta. So you would create a zone and zone your host to those virtual worldwide port names. And I'm going to demonstrate that. I'm going to create a zone for a host that I've created, and I'll show you on the storage how that checks in. Just so you know, if I go look at the storage now, and I did an LS port FC on the storage after changing it to transitional, you're not going to see those virtual worldwide port names from the CLI. Actually, the only time you'll see them is once your host is mapped to those. You can do an LS fabric, and then you can do an LS fabric -host and put the host ID in there, and you can actually see what worldwide port name is checking into, and then that's when you'll see the new virtual worldwide port name. But if you just turn it on transitional thinking you're going to see more ports at the LS port FC command, you're not. So let's go into mapping a host. Okay, I have this temporary host I set up called mport ID. It's an AIX host, and I just want to show you its current setup before we make the zone changes, so you can see the changes actually occurring. So we have a single HDisk, which is our root VG, and if you go look at the HDisk, it's got a UID that ends in, looks like here, 00109. We can actually go look at that at the storage layer to validate, which I'm going to pull up now. So you can see 109 and 109. So that is the HDisk. Let's look at our paths. It has 4 paths, so a single virtual fiber channel at the host is going to both nodes. So it's zoned in its essence to a zone that goes for one port that goes to both canisters, another port goes to both canisters. So you get 4 paths. So what I'm going to do is I'm going to shut down this host and change its zoning to go to the virtual worldwide port names. And before I do that, I want to show you one last thing here. LS host is 21, so we'll do LS fabric -host 21. And you can see it's checking in to these interfaces, which is local port 1s on each canister. and that is not our virtual worldwide port name. So for Echo Charlie, Baker 215, right? It's not Baker 25. So this is still physical worldwide port name. So we're gonna shut down this host and make the zoning changes. So let me bring the host back up. Shut down. All right. And while that's coming down, let's go to the zone changes. All right, so I have pre-created a couple zones that will map the host's virtual fiber channel adapters, the worldwide port names. In your case, it might be physical, to the end port IDs on the V7000, and I just want to show you those two zones before I activate them. So here's the first one. We have the end port ID at the host level, and the two end port IDs at the V7000 layer. Excuse me. And the other one is, there you go, same situation. Second host port number and the V7000 import IDs. So I'm going to add those to the configuration and then activate them. Here. And there they are. So you have your two 5s that we saw earlier that relate to the import IDs on the V7, and we have our two host worldwide port names. So now I'm going to activate that host and bring him online. And we will demonstrate what paths you see now from his side and from the storage side. Okay, the host is finished firing up IPOing. So let's log in and see what it sees. So, if you remember correctly, this is the unique ID for that volumes to remain the same. If you do an ls path, you can still see it. It still sees its 4 paths. 2 fiber channel interfaces, but 2 paths per interface, so a total of 4. Now, if we go look at the storage, and do an ls host, here's the host, ls host 21. He is logged into 2. These are the, just so you know, these are the hosts you see offline. These are the hosts it applies when for live partition mobility, so you can ignore those. That's something PowerVC does to ensure you can do an LPM. But the ports you're really concerned with are 12 and 10, and they're active. If we do an ls fabric -host 21, this is where you will actually start to see the new import IDs on your storage, your V7000 SVC, whatever you have. You can see here it's the V25. So if you remember earlier, that is the worldwide port name for those virtual interfaces. So there you have it. It's logging into the virtual import IDs. So the last thing I want to do here is I want to simulate a node failure and show you how the storage handles that. So what I'm going to do is I'm going to log into the service IP and put one of the nodes into a service state, which will simulate a node failure. And so here's our service assistant dashboard here. going to take node 1 and I'm going to put him into a service state. Lost connection since that was the primary node at the time. Go into node 2 here. We'll give it some time to acknowledge the service state of node 1. Let's go look at our host and see if it still sees its pass. Everything's still enabled. If we go look at our storage, sorry, that's the zones. When we do an LS Fabric host, you can see now that everything's on node 2. Still has your 4 pass, but they're all going through node 2. If this was still in the old configuration, the old setup, you would only see it 2 pass to node 2. The other pass would never have come over. So that's the new feature of the import ID. So as soon as there's node 1, it's in a service state, so I'm going to bring it back out of a service state. And you'll see it take back over. It will take probably a couple minutes for it to go through its boot up process for the node. Okay, those 2 paths disappeared. They should come back any minute now. There you have it. Node 1 took them back over, put them back in their home position there. So that is N-port ID set up in a nutshell. The last thing we would have to do is do an enabled, which I'm not going to do in my situation because I still have hosts that are accessing the physical ports, and that would disable their I/O, so I'm not going to do that for you. But you would just do the same command, change I/O group, target port mode enabled. A couple things to note. As far as code updates, when you're doing a code update on a V7 or an SVC, it takes 1 node off at a time. As of right now, I actually tested this last week. This feature doesn't occur during a code update. So when node 2, for example, goes offline for its upgrade, it will not roll swap those. It will not transition those virtual N-port IDs over to node 1 in this case. That doesn't occur yet. So this is strictly for node failures. If you have a canister go offline and SVC go offline, that's what this is addressing. It's not moved. Hopefully it's on the roadmap, but as of right now, code updates are still. You're still going to see missing paths at your host layer when that node goes offline for that upgrade. But hopefully that's informative, and that is IBM's new N-port ID feature. Thanks for watching.